Dear auditors, if you have heard all of the fundamental particles in the standard model but never have seen how these 61 very small points could be integrated in a standard system, matching all together, then you've come to the right place here to follow Gell-Mann, the investigator of the quarks, even 60 years ago, but since then no other picture exists. The basis of the GeoGebra program, cleverly devised by Gell-Mann's eightfold way, is the stereo coordinate system, spin, strangeness, charge, with the neutron baryon and the modern Higgs center point odd, odd, odd. As you see, the algebra point with the 3 coordinates lies on the left and the construction step on the right. Then we go to the next step, the half spin. Left with the negative left rotating, e.g. the mi neutrino, and right with the positive right rotating and bigger tau neutrino. Both sides united in a closed circle, thanks to Gell-Mann choosing the strangeness dimension and the incident charge to draw a stereo picture. The proton baryon, the pion meson, the antineutron, the symmetry breaking antiproton, because it is a little bit smaller than the proton. Therefore, only matter exists now, and not antimatter anymore. And the cowl meson are all connected in this sextet between the strangeness axis +1 and -1. These corner points we connect together, especially the neutron line from the left to the right in the neutrino half-spin circle. We get the cross points antineutrino and the electron neutrino and enlarge the sextet by the double-loaded baryon double delta on the strangeness axis +1 to get the incident charge +2, +1, odd, -1 and -2 crowns. And the same with the other left baryons inversely charged from -1 on the strangeness axis +1 to +1 on the strangeness axis -1. We fix the electron, the positron, and draw the strangeness lines connected by the half-spin right and left, and connect the other corners until we get exactly Gell-Mann's basic construction with the 6 centers of gravity of the 6 triangles, which we call the quarks, namely up and down, strange, and later the subsequently detected CERN, bottom and top. The 3 double triangles in green, blue and red represent the 3 mass increasing quark families. They have been projected to the neutral plane in order to see the upper and lower parts better. On this neutral plane there are also the weak power bosons photon and Z, which we connect by the boson 1 spin circle. 1 charge quant below the neutrino neutral plane there lies the muon and the tau, or tau. So we had better turn the axis and get a bit of strangeness for a real stereo picture. The figure you see is that the W plus and the W minus ray are connected together to a charge axis with the two quark half-spin levels on 2/3 and -1/3, so that we can draw the electron half-spin circle because we have 3 -1 charged points, electron, muon and tau. As the standard model proposes that each half-spin point has its antipoint, we get the anti-muon and the anti-tau by inverting the scenes or constructively by placing reflection rays through the Higgs stereo point. So we get the anti-electron as positron half-spin circle, and as fourth point on both circles, the spin-inverted Pauli counter-electron and anti-electron respectively. Therefore, there are 4 particles connected in both half-spin circles, W plus and W minus. The couple muon and tau, as well as big initialized term electron and the spin-inverted small initialized electron, similar to the neutrino half-spin circle, as each half-spin point has its antipoint. After marking the 4 center points with a white ball, we get the -2/3 half-spin circle with anti-charm, anti-up and anti-top, and the other 1/3 anti-half-spin circle with anti-strange, anti-down and anti-bottom. The center of gravity points on the red projected triangles on the neutral plane are also shown. According to Pauli, all these quarks must have their spin-inverted counter-quarks, so that each leveled quark half-spin circle would get 6 different quarks, e.g. on the -2/3 anti-spin circle, additionally anti-up, anti-charm and anti-top. But as baryon can have 3 equal but distinguishable quarks, there should be another 3 quarks more in the spin circle, which can be done by quantum chromatic dynamic, abbreviated QCD. Therefore, we construct through the white balls on the W plus and minus ray at 2 and 1/3 these colored QCDs, because they consist of the same 3 colored quarks, blue, green and red, and the antiquarks as yellow, magenta and cyan blue, respectively. All 3 together result again in white, necessary for each existing baryon containing these 3 different colored quarks or 3 antiquarks. We completed therefore the -2/3 counter antiquarks with the antiquark colors and indicate the +2/3 counter quarks with small initialized terms, charm, up and top, with the quark colors. We continue with the -1/3 counter quarks, small initialized, down, strange and bottom, and finish with the 1/3 counter anti-quarks, anti-down, anti-strange and anti-bottom, with the anti-quark colors also called anti-green, anti-red, anti-blue, meaning, of course, magenta, cyan blue and yellow respectively. To clear up the 2 times 2 matching quark spin circles, we connect the corresponding quarks and see the German declarations. The white balls are the 2 spin circle centers of the W plus 2 1/3, lying on the positive W ray, and also the 2 spin circle centers of the -2 1/3 lying on the negative W ray. On each quark spin level lie 9 quarks or 9 antiquarks. The quarks in the baryons are fixed by gluons containing the margin-colored signs. To place the gluons on the 1 spin circle, I used the tangent equation, radix of boson spin minus squared fermion spin. To get the standard model completely, we rotate again the axis and add the 6 double-colored gluon bosons, 1 quark color side and the other with anti-quark color, and the other sides as 4 and 6 colored, all on the 1 spin circle as tangents of the inner half-spin circle, filling out the 8 interstices of the 9 quarks of each of the 4 quark levels with the 8 gluons to keep them bonded very strongly together in the baryonic nucleus. At the end of the 7 planes of the standard model, we can test the precision of the picture by turning the axis and checking the Higgs crossing lines. But finally, we can turn and rotate the whole system and look at each particle with all the possibilities of the GeoGebra program, e.g. checking electrons, neutrinos, quarks, gluons, bosons, and the algebra points given by the 3-dimensional construction, enlarging and so on. Well, I hope that the graphical system could be a bit better for remembering and detecting than examining and checking a strange mathematical equation with over 20 parameter constants. I am wondering why the particle physics never published any picture after the investigation of the Higgs particle, but only showed a CERN box of independent bricks and put all the power to speculate and calculate the following SUSY supersymmetry with hypothetical grey matter particles. If the immense mass of neutrinos is not enough, if you have seen serious mistakes and you know better, please demonstrate them and let me know soon by email, because I am already 85. Thanks for your concentration and interest. for the part